In this lesson, we'll see how we can use the MIB color interpolate node. So the color interpolate is a mental array node that will allow us to remap grayscale values to some kind of an RGB value. So we can illustrate this if we take a look inside the mental array nodes, and we can go down to data conversion, which is where we'll find the MIB interpolate, and let's just drop this in. There we go. Now, in order to illustrate this, we can connect in some kind of a black and white texture. So just as a very simple illustration, we'll use something like a Maya cloth. Now to connect this in, all we need to do is go to the interpolate node, middle click on our cloth texture, and drop it into the input. Now we can also connect in a material in this slot if we needed to. Now as far as the interpolate node, right now we don't see any kind of a difference really between the original and this new one. And that's because right now the color values are set from black to white. So basically what we're saying is that the darkest parts of this image, color 0, will be mapped to black. The brightest parts of this image, color 1, will be remapped to white. So that's why we really don't see any kind of a difference. However, if I were to come in now and give this color 1 some kind of a orange color, we're now remapping the brightest parts of this image to orange. Now if we wanted to, from this point forward, every color that we start to add on top will correspond more and more to the brightest parts of this image. So if I were to come in, let's say to color 2, and if we wanted now to add some kind of a very, very bright orange texture, so that way we could start to get a little bit more kind of a lighter color in here, you'll notice even after we change this color, nothing happens. And that's because right now, if we take a look all the way up at the top, the number is set to 2, which means it'll only calculate the first 2 color slots. So if we wanted to calculate this third color slot, we now increase the number to 3. And now you can see that this very light color is now being remapped to the even brighter portions of this image. Now you will, however, notice that once we do that, this image actually becomes very, very washed out. So this is where we start to use the weights to begin to control that. Now right now the weights are set to their corresponding color values. So weight 1 controls color 1, weight 2 controls color 2, and so on and so forth. Now if we wanted to adjust the weighting of this, what this will do is adjust the blending of the color above and below. So right now color 1 is the only one of these color chips that has a color above and below. So if I were to adjust now the weighting of value 1, you can see how it begins to now increase its bias more toward either the dark or the light portions of this image. So you can see right now with the weight set to 0 that this color is actually aligned very heavily toward these darker parts of the image. As we begin to increase this weight, it will now start to factor that off and darken up some of these areas. So that will now kind of help us reveal some of these colors that we've now assigned, again, to this brightest portion of the image. Now again, if I wanted to add some kind of an additional color, now color 3, just for illustration's sake, we'll make this a little bit different color. You'll notice, again, color 3 makes no change. So we need to now go up to the number and make sure it's set to calculate 4 of these color slots. And once we do that, you give this just a moment to update. You may not see much of a difference right away, but now if we come into color 3 and now begin to adjust some of these different values, we can now find our weighting between these different values. So right now, weight 2, again, corresponds to color 2. Now that we have some kind of a color above and below, we can now adjust the weight of this color 2 without any problem. Now on color 3, you'll notice if I adjust the weight, nothing happens. And again, that's because if we want the weighting to work correctly, we have to have a color above and below. Color 3, we have nothing set above it, so as we adjust the weighting of 3, nothing happens. So again, we start to increase this, and this blue value is now the brightest portions of this particular image. Alright, so that gives you an idea of now how we can use this MIB color interpolate as a way of assigning color to any kind of actual scalar image or anything that has black and white. and we can then come back and begin to give that some kind of coloration.